can start. Thank you. Hello, everyone. My name is Loredana Judele. I come from Technical University of Iași, Romania. And I'll try to present you our paper named Thermal Conductivities Determination of Synthetic Wood with Recyclable Waste using advanced experimental method and numerical simulation. This is about one of our former research, and I'll try to change the slide, but I don't know. Yeah, I'll try with mouse because yeah. The summary of the presentation, introduction, materials and method, results and discussion, and of course, conclusions. Let's say about something about our study. It's a study about synthetic wood. We obtained the samples in a lab, and for this paper we measured thermal conductivity. The particularity of this research is that the samples are obtained entirely for recycled materials from wood biomass actually. And we added other compatible waste like seeds and other materials. Of course, we use the design of an experiment, the method design of experiment, which offers us the possibility to decrease the number of the samples. But with maximizing the information on the research results. It is a modern method of planning and experimental analysis that offers the users a suitable tool for obtaining information, the necessary information for research of new materials, and we actually we use this method very much for all kinds of materials, not for only for synthetic wood. We use this method for concrete, mostly for concrete samples, and other kind of samples, mortar samples, and with all kind of additions. And it's okay because we obtained good results. Why we use the waste for our samples? Because waste management, looking in a European Union report, yes, between 2010 and 2020, like you can see in the chart, the best ranked country in Europe was Finland, but in the opposite country like Russia or Turkey had almost 2 tons per capita, 2 tons waste, which means 10 times less, while Romania is above European Union's range, obtained 5 tons of waste. It's a lot of waste. This is the reason we try to obtain new materials using, of course, waste. But this is another discussion. I'll try to present our paper right now. Design of experiment method, black box. The design of experiment method is an advanced method of planning, analysis, and optimization of complex problems like black box. In black box, like probably you know, things happened inside the box. But not all the things inside the box are directly controlled by us. But thanks to this technique, we were able and we continue to be able to identify influential variables and mathematical models for optimization process. So in the left side, you can see the factors x1, x2, xn which enters in the black box. Then black box, like I said, since it's happened, of course we have also non-controlled variable noise called noise factors, and in the end we obtain a response or many response, and of course we are interested in this response. It's very important for us for our research. um, the question we used to put one when we use design of experiment or other method. First, what is the most influential parameter? We have to identify the most influential parameter. The second, how should it be changed? What is the minimum? What is the maximum? And third, how to study the interaction between different parameters. These are our constant question, let's say. And objectives for design of experiment: simultaneous multivariate exploration of the space of uncertainties, identify and quantify sources of variation in response the factors, fit a simple model linking the response to the selected factors. This is usually a problem. And very important, to the identification of process parameters, which it happens usually by experience, this experience coming from feedback, prior knowledge, or expert opinion. Of course, we can identify by consulting a specialized literature in the field, reviews, articles, etc., and by deduction, but this requires a lot of experience. It's not so simple, and probably you can make mistakes, some kind. So for using design of experiment method, we have to identify some parameters, like the materials we used. We used the adhesiveness, biomass, the waste, different waste, and another kind of materials. Of course, operator and other influences appears in this part of parameter identification. We choose for this study, we choose the like parameter X1 recycled polystyrene, and like parameter X2 sunflower, it's a mistake, I apologize, X2 is sunflower husk waste. So all specimen, all the samples were obtained by subjecting them, after we obtained, we subjected them to thermal treatment. Why thermal treatment? Because thermal treatment accelerates the reaction and drying process. And we choose 155 degrees Celsius, and we keep the samples for 30 minutes. Of course, the thermal treatment facilitates the creation of chemical bonds between the different components of the samples. Speaking about wood or wood waste, the thermal decomposition begins at, let's say, 100, a little bit over 100 degrees Celsius. And when we reach 2 degrees Celsius, it's greatly accelerated the reaction and the decomposition of the materials. And the maximum level is 275. Thermal degradation of the wood may also occur during prolonged exposure below 100 degree, but this is another problem. The flash point, because this is about, the flash point of wood is between 200 and 275 Celsius degree. Of course, we can reach the pyrolysis, but like I said, this is another discussion. This is the two of our mixture composition of the sample. Like you can see, we used wood waste fine parts, wood waste coarse part, adhesive. It's a kind of urelite adhesive. It's a kind of clay. Cement, we used cement, recycled melted waste, alcohol, and an additive hardener. In the second sample, we used also in plus sunflower husks and recycled cement. We try also with recycled cement. We made all kind of mixture composition. This is only an example. We made a lot of samples, and we tried for every kind of samples. We tested them actually. Uh, like I said in the paper, it is proposed to investigate the synthetic wood sample obtained by the combination of wood mass waste and an adhesive and another kind of waste. These are two others mixture composition. Like you said, there are differences between them. And like I said, we tried all kinds of mixture composition to choose the best of them. Like you can see in this part, we also introduced recycled polystyrene and sunflower seeds, shells, like waste. And what I want to present to you like right now is we introduced the samples in these double climatic chambers, yeah, to test some technical characteristics like thermal conductivity. We determined thermal conductivity of this kind of samples. These are geometric characteristics of the specimen. You can see here the length, height. The temperature in cold climatic chamber was of the beginning in a part of the chamber was 15 degrees, and in another part of the chamber was 25 degrees. And we subjected these samples to a difference of 10 degrees temperature, from 15 to 25 degrees Celsius. And we recorded the heat flow for every 10 minutes for at least 4 hours. And this was for 16 samples obtained from the 4 experience plants. Of these, 4 were chosen for this study. I presented you before. Modeling the hydrothermal behavior of these new materials allowed to experimentally determine the thermal conductivity. And we choose the like parameter geometry. We made a discretization of the samples in triangle elements. One of the factor was material, like polystyrene and wood. Polystyrene it's yellow and wood it's gray. We choose like parameters thickness of the samples, and of course we studied the thermal change for the samples. And like results, the parameters we obtained, the results were about thermal flow and the difference of temperature. In these charts, you can see here on the left side the variation of temperature according to the thickness of the sample. You can see Celsius degree and the thickness of the sample. And on the right side, you can see the variation of the heat flux according to the thickness of the sample, the chart of this variation. Also, these are two results obtained for the thermal flow. And these are the results, experimental results. You can see here on this column, experimental thermal conductivity comparing to numerical thermal conductivity. Practical results and results obtained using numerical uh, um, thermal conductivity. And we are very pleased to to see, we were very pleased to see that the difference, like you can see, is very small. It's really very, very small. And this is a wonderful situation because usually not not usually you can obtain such a small difference between experimental and numerical difference. The results obtained and presented in this table show us the concordance between the two approaches and strengthen our conviction that both experimental test and numerical modeling prove that the hypothesis considered is the numerical of the numerical modeling about heat transfer phenomenon. It's as well as the protocol of the experimental test in double climatic chamber, like I showed you before, are perfectly viable. Like I said, the difference is very, very small. And like conclusion, this paper was a comparative study to determine the conductivity of synthetic wood obtained with the addition of recyclable waste. The main purpose was to highlight the thermal characteristic to the new material, but also to verify and validate, numerically validate this characteristic. We tested several specimens like I showed you in double climate chamber and determined the energy flow that crossed the new material. The values obtained for the thermal conductivity of the synthetic wood are between like you said, 0.071 and 0.107 experimental, and between 0,073 and 0,109 numerical, which places it in the category of insulating materials, and that is very good considering that its rigidity it's quite good and can be used for both thermal sound insulation and perimeter closure. Um, this is our area. Our goal is to obtain a synthetic wood that incorporates as many recyclable wastes with compatible characteristics from a physical-chemical point of view, but that will ultimately meet the requirements of resistant and hydrothermal, so that it can be used in construction, but also in wood processing industry, and not only for waste management, of course. Thank you.